Kinetic molecular theory is a model that describes the behavior of gases, and it's based on these 5 underlying assumptions. First, that the gas particles are in constant random motion. Second, that the combined volume of all the gas particles is going to be negligible when compared to the container volume. The third assumption is that all attractive and repulsive forces between the particles are going to be negligible. The fourth assumption is that collisions between gas particles can occur, and kinetic energy can be transferred from one particle to another. But the average kinetic energy is always going to be constant at a constant temperature. The final assumption is that the average kinetic energy of the gas particles is going to be proportional to the absolute temperature. That is, it's going to be proportional to Kelvin, but it won't be proportional to degrees Celsius. And there are a number of implications for kinetic molecular theory. The first one is that if you increase the volume and hold the temperature and number of moles constant, your average kinetic energy has to remain constant. Because the average kinetic energy is constant and the particle masses haven't changed, you can conclude that the particle speed also has to be constant. If the particle speed is constant, but the volume of the container is bigger, that means that particles have to travel further before they reach the container walls, which translates into fewer collisions with the wall per unit time. And because the force of the gas particles colliding with container walls is going to be related to pressure, fewer collisions means a decreased pressure. And all of that is a long, somewhat roundabout way of getting to the idea that increasing the volume decreases the pressure, and vice versa. Or put another way, volume and pressure are inversely proportional when temperature and number of moles remain constant. The second implication is that increasing the temperature while holding volume and number of moles constant means higher pressure, for similar reasons to those just described. And again, putting this a different way, temperature is proportional to pressure. The third implication of kinetic molecular theory is again going to be based on similar reasoning, and this implication is that increasing the number of moles while holding the volume and temperature constant means higher pressure. And again, writing it a different way, we can say that N is proportional to P. Number of moles is proportional to pressure.